If you want to find more of my Maths YouTube videos quickly and easily, visit my website, click on the link for Math videos at the top of the home page, scroll down for the section of Maths you need, then click on the link for that playlist. Looking here at what standard form is and why it's used. It's quite useful for very big numbers that have lots of digits, or very small numbers where there are several decimal places. It's a more efficient way of recording numbers with lots of digits in, but you have to provide the information as to what you did to that number to get to where it was in standard form. So here's an example. We have 6,700,000. We have to make this easier to record by first dividing it by multiples of 10 until there's just one significant digit before the decimal point. That whole number before the decimal point has to be between 1 and 10. So first thing we're going to do is divide this number by 10. With a whole number, just imagine there's a decimal point on the end of it, and then you move it one place to divide that number by 10. Now we divide it by another 10, so that's 100, and the decimal point moves another place. And we keep dividing it by another multiple of 10 until we end up with just the 6 before the decimal point. Now we just need the significant figures, so we can get rid of those zeros at the end. And we have 6.7. How many times did we divide the original number by 10 to get to 6.7? If you've recorded it like this, where every time you divided it by 10 you've added a 0, you can just count the zeros. 1, 2, 3, 4, 5, 6. Another way you can do that is to just count the decimal places that the decimal point moved in the original number. If you imagine with a whole number there's a decimal point on the end of that number, it moves one place here, that's one lot of 10, 2, 3, 4, 5, 6. We divided this number by 10 6 times. When we give this information to someone in standard form, they have to be able to take the number back to what it was originally. So you have to let them know what you did to that number to get it to 6.7. So you divided it by 10 6 times. The person converting that needs to use the inverse calculation. 6.7 times 10 to the power of 6, and then they will be able to take it back to that original number. Here's a similar one. It just has more significant figures, but it works exactly the same. So we have 359,000. We're going to write it in standard form. We need just one significant digit in front of the decimal point. So we're going to keep dividing it by 10. So that's one lot of 10, 2, 3, 4, 5. Now we can get rid of those zeros. We have 3.59. It's going to be times 10 to the power of something, so we're going to count the zeros to see which power that times 10 is going to be. 1, 2, 3, 4, 5. Or again, you could just count the decimal places in the original number. 1, 2, 3, 4, 5, until that decimal point is just after the 3. To get to 3.59, we divided by so many lots of 10. The person who has the number in standard form has to take it back to the ordinary number, so they're going to do the opposite. We divided by 10 5 times, so they're going to multiply by 10 to the power of 5. This is slightly different. Here we have a very small number. There are several places after the decimal point. We still have to make sure we have one significant digit before the decimal point, and that's going to be the 4. So what we're going to do this time is keep multiplying the number by 10 until that decimal point moves between the 4 and the 5. So times by 10, times by another 10, times by another 10, and another, and another, and another. And we've got to 4.5. And we can take those zeros off the beginning. How many times did we have to multiply that original number by 10? Again, you could count the zeros. 1, 2, 3, 4, 5, 6. or you could count the decimal places. So there's where the decimal point started off. How many places to go between the 4 and the 5? 1, 2, 3, 4, 5, 6. We had to multiply that original number by 10 6 times. The person who gets this number has got to go back to the smaller number. So instead of multiplying, they're going to be dividing. But when we're using standard form, we still tell them to multiply by 10 to the power of something. When we write the power this time, remember we multiplied the number to make it bigger. So the person converting this back has to make sure they divide it. And instead of saying divided by 10 to the power of 6, they're going to say multiplied by 10 to the power of minus 6. And that will tell them that they've got to keep dividing by 10. And here's a similar one, just with more significant digits. So we're going to write this number in standard form. We keep multiplying it by 10 until that first significant digit, the 9, is the other side of the decimal point. So multiply by 10, another 10, another. How many times did we multiply the original number by 10? Count the zeros or count the decimal places. So looking at the decimal places, how many places does that decimal point move to get after the 9? 1, 2, 3, 4, 5, 6, 7. 7 times. We just need those significant figures so we can get rid of the zeros. Now again, remember, we've made a very small number much bigger. We've had to keep multiplying by 10. So the person who converts this back, they're still going to multiply by 10, but instead of to the power of 7, remember we multiplied it to make it bigger, so they're going to multiply it by 10 to the power of minus 7. Just remembering those rules. If you had to divide a big number to make it smaller, to get it to standard form, to convert it back, you must multiply it by 10 and give it a positive power. If you had to multiply a smaller number to make it bigger, to put it into standard form, to convert it back, times it by 10 and give it a negative power. If you found this video helpful, please click the thumbs up button and subscribe to my channel.